Now see, in this question there is a point P that moves inside this region, right? Point P is moving on the xy plane in such a way that this condition is satisfied by the coordinates of point P, right? And it's given that x lies between 0 and 2, so that's how point P is moving, that its x coordinate is between 0 and 2. Now we have to find the region in which point P is moving, or we can say find the area of the region. We have to find area of the region of all the possible positions where P can move. So basically we have to find area of the region represented by this inequality, because point P, coordinates of point P satisfies this. So we have to find area represented by this inequality in two-dimensional plane for x between 0 and 2. So to find area represented by this inequality, you see you'll have to make cases. So the region is small 0 to 2, so it's no harm in making cases and do it inside a case and simplify inside a case. So we make first case x. We see basically we want to get rid of this greatest integer sign, and critical points of greatest integer sign, definition change of this is at every integral value. So that's why we choose intervals 0 to 1 and 1 to 2, because this will remain same between 0 and 1. Then between 0 and 1 it is 0, and between 1 and 2 it is 1. So first case is x between 0 and 1, greatest integer becomes 0, and greatest integer of x plus y plus 1 is 0. Now we'll further simplify this. When greatest integer of this quantity is 0, it means this quantity lies between 0 and 1, right? And we'll plot this region. Same when we make second case, x lies between 1 and 2, greatest integer of x is 1. It means we have this, and this means this expression, quantity inside the greatest integer is between 1 and 2, because if I take greatest integer of a value between 1 and 2, it is 1. So it means if greatest integer is 1, the value is between 1 and 2, so the other way around. Now we'll plot this inequality and this inequality between 0 and 2, right? And calculate and then just count the total area. Point P can move here and point P can move here. Now so to plot this, you can see we can further write this as y lies between minus x and minus of x plus 1, that is minus x minus 1, right? And this is x between 0 and 1. So for x between 0 and 1, y lies between minus x line and minus of x plus 1. Between 0 and 1. So between 0 and 1, y can take values at every value of x. You see that for at every value of x, y lies between this and this, greater than minus of x plus 1 and less than of minus x. So for this particular value of x, y can take these values. Similarly for all these values of x, y can take values between the two curves. So this inequality is representing this area on the graph. Similarly we can simplify this. This means y can take values, y is greater than minus x and less than 1 minus x. So this is minus x line. We'll draw 1 minus x line. This is 1 minus x line. When x lies between 1 and 2, y can take values between minus x and minus x plus 1. It means y can take these values. So basically now This is the area represented by this inequality, or this is the area in which point P is moving. Now we'll calculate this area. To calculate this area, we can, this is a parallelogram, so we can calculate area of this triangle and double that area. This is length 1, right? And this is, you can see this is 1, this is 1, so this length is root 2. This, from this right angle triangle, this length is root 2. This is 1. We can draw perpendicular from this point. This angle is 45 because this is y equal to minus x line, so this is 1 sine 45, 1 by root 2. So using half base into height formula, half base is root 2 and height is 1 by root 2, because height is 1 into sine 45, so it is 1 by root 2. So area of this triangle is half units. But you see, we have 4 such triangles. One triangle is this, and there is a congruent triangle here. Again, area of this is half, and similarly area of this and this would be same. Area of these two parallelograms are same, so total area is 2 times area of parallelogram, and area of parallelogram is 2 times area of triangle, that is half units. So total area is 2 units.